In fact, A and A2, they are exactly the same thing. Is A A2? Yes. What that means is A2 is pointing at A. Is A equal to A2? Item by item, yes, right? But what this means is when I change A to 9, you see that A has been changed, obviously, but A2 has also been changed because A is A2. The two variable names contain an arrow pointing at, or rather A2 is containing an arrow pointing at the container A. So whenever you say what's the value inside A2, there's an arrow there, so you follow the arrow points to A, and you look inside what's the value contained in A, and that is this list, the mutated list, right? So no wonder when you look at A2, the value has been changed. And likewise, when you change the value of A2, the last value, we change it to what is it? 999. Okay, so A2 obviously should have this. But what is the value of A? Oh, same thing, right? Because when you change A2, A2 has an arrow. It doesn't have anything. So Python says, okay, the value is found where? In A, is it? So it goes to A, container A, and looks up the value of a list of 9, 3, 88, 9, and modifies that to 999. So next time you say what is value of A, of course it's going to point to this thing. So there's a problem. Good and bad. Good and bad. Sometimes we want this. That means A2 is just an alias. I don't want to call A. I want to call it A2, but I don't want to change A anyways. You know, something like that. So then whenever you touch A2, A changes. And that's nice and efficient sometimes, especially when you pass a huge list set, tuple, dictionary to a function. Then you don't want to copy the whole thing, right? Because it's 10 megabyte large. And you copy the whole thing inside, you modify it, you pass back, it will be problematic. Very slow, very inefficient, very unnecessary. So you just pass a pointer along. Just say whenever you need to know A, just access A2. What is A2? There's an arrow pointing back. That guy has it. Okay. But in times when we really want to say, you know what, A2 is A2. You can do all you want, but don't touch my stuff, right? And that means you want a copy of A2. So A is this, A2 is this. Now I say A2 is A.copy. Make a copy of A, photostat it, right? Now we have a photostated copy version of A, and we modify A2. Guess what happens? Original, intact. So let's try. A2 of the last item, change it to 8888. So what is A2? What is A now? Same, of course, because it's a copy, right? Now, is A equal to A2? Because they're different. Is A and A2 the same thing? No, because I've changed it. Let's try again. In a fresh copy, right? I just photostated, right? I haven't touched anything. Let's look at A. Let's look at A2. Same, looking the same, but are they actually duplicates? Because when we know in real life, you have an original copy and a photostated copy. Are they the same? You may be asking. What do you mean, are they the same? Correct? Because you're asking. Are you asking about contents being exactly the same? I will vouch for it, yes, because I did the photostating. But are you asking original means the same as duplicate? I will say no, right? So are you saying the content is the same? That is the original content line by line the same as the photostated content? That is what the double equal sign is checking. Content-wise, yes. Now we ask, are you saying that the original copy, that piece of paper, is the same thing as the duplicate paper? No, right? Because in land title deeds, in birth certificates, in national registration IC cards, photocopy and the original copy, even if you cut down to the same size, they're different. So we ask, is A the same as A2? This time, we have a very nice X-ray eye to see that, no, they're different. Even though illusionally, we think the content is the same. Okay, so be very, very clear about composite structure here. The contents might be the same, but they are two different plastic bags. They are two different structures. Versus they are exactly same content because they are actually the same structure, right? So it will always be exactly the same. Is always true. Double equal is also always true. Okay, so that's why we made a copy. Let me rerun just to make sure that I didn't accidentally upset the test programs. All right, so we made a copy and we printed out, first of all, using the IDA, I know it is this line, to see that C select 0, 1, 2, 3, that's 5, right? D is a copy and that's 5 and so on. So here we are trying to change D because it's a copy, it will not affect C like this. So D3 is being changed, but C3 is still 5. And then we can, of course, change the fourth element of E. All right, what is E? E is equal to C. E is just an alias pointing at C. So whenever you ask for E, Python says, container E, what do you have? It has an arrow. That guy has my value. So it goes to which guy? C guy, the C guy, right? So if we change the value of E, then we change the value of C as well. So when we change the value of E to 33, we see that C value, even though we never say C square bracket 3, it is also being changed because literally they are the same guy, the same data value. Okay, so have this notion of pointer. That guy has it. And whenever you make a very innocent assignment like this, equal sign, it is always a pointer. That guy has it. If the original data is a structure, it's a composite. Now, we can also get rid of, so we can pop a particular position for list, and of course not tuple, because if we pop a tuple, we are changing the content, and that's disallowed. So we can pop a list, and where is it? 0, 1, 2, 3. So after popping, A should not have the value 5, and the popped out value, the extracted value, is being returned and is stored in V. Okay. Next, we have delete the content of D from position 3 inclusive all the way to the end. Now from here we can see what is the value of D. D is a copy of C, right? So we change it 4, 3, 88 and so on. And along the way we change the 5 to 99, so it should have been 99, 9 and so on. Say 0, 1, 2, 3. So we will delete the 99 all the way to the end, leaving D having only 4, 3, and 88. Okay. Then finally, we can also say D dot clear. D dot clear, right? So D dot clear means clear up all the contents of the list. Don't delete the list itself. I still want the plastic bag, but I want all the contents removed, right? That's the different notion from delete the whole plastic bag. So let's try that out. If I just do a quick creation of the list, so D2 is this, right? If I also say D3 is the same list, and of course D2 and D3 they are the same content, right? But D2 is not the same as D3 because I created them separately. I do a manifest type creation separately that is going to result in two different copies that accidentally have the same content. So now if I say d2.clear, remember I'm running this as a function associated with the list data type, right? So dictionary may not have clear, but you can check it out. A tuple will not have clear because you're changing the tuple, so cannot have it. Versus deleting D3 completely. Okay, so if we understand correctly, clearing the content of a plastic bag leaves us with the empty plastic bag. Throwing away, deleting the whole plastic bag leaves us with nothing at all, right? Totally undefined. I don't have plastic bag. Which plastic bag you want from me, right? So that's the idea. And then a few more quick intro to the very useful functions. We can reverse a list. Right, so originally the list was looking something like 4, 3, and all that. Now we put it backwards first, 2, 4. So it's nice to do this, and of course to sort in certain occasions. In many occasions, we like to sort, and immediately the numbers are sorted. Well, the results are not clear when you have a mix of various different types, like integers mixed with strings and all that. So even if you don't have error, don't try to do that because you don't really know what's the basic default understanding of the comparisons uh, were when they were sorted. So don't try to do operations that we are not very clear of, even if Python didn't give an error.